Hello, calculus fans. All right, so we're going to let R be the region under the curve, y equals 1 over x plus 3 quantity squared, and above the x-axis, where x goes between 2 and 5. We'll take that region and revolve it about the y-axis to get us a solid. And we want to find the volume of this solid. Here's a picture. So we're taking that region under the curve between 2 and 5. We'll revolve that about the y-axis. We're going to slice it vertically, so with delta x slices. If we sliced it the other way, then we'd have some problems with changing outer radii of our washer. So the slice is going to work out better this way. Okay, so the radius is x. That's just the distance from the axis of revolution to the slice. And the height is just going to be the y value, so that's 1 over x plus 3 quantity squared. So that gives us a delta V, which is 2 pi times the radius times the height times the thickness. So 2 pi x times 1 over x plus 3 quantity squared times delta x. All right, so that gives us an integral of 2 pi times the integral from 2 to 5 of x over x plus 3 quantity squared dx. A couple of ways to evaluate this. You could make a substitution, or this could also be done with a partial fractions decomposition. Let's try it that way. So to decompose x over x plus 3 quantity squared, we'll get a over x plus 3 plus b over x plus 3 quantity squared. Heaviside cover-up method, that allows us to solve for b. Okay, go ahead and work that out. See what you get. So if you do the cover-up method, then you end up getting b is equal to -3. Now, cover-up method won't work to get a. So now what we have is x over x plus 3 squared is equal to a over x plus 3 minus 3 over x plus 3 squared. Let's go ahead and plug in x equals 0. We can plug in anything we want to try to figure out a. The only thing we can't plug in is -3, because essentially we've done that in using cover-up method. So if we plug in 0, we'll get 0 is equal to a over 3 minus 3/9, so a is equal to 1. All right, so here's our decomposition. X over x plus 3 quantity squared is equal to 1 over x plus 3 minus 3 over x plus 3 squared. Okay, back to the volume integral. So now we should have the integral of 2 pi times the integral from 2 to 5 of 1 over x plus 3 minus 3 over x plus 3 squared dx. Each of those, not too bad to anti-differentiate. We get log of absolute value of x plus 3 plus 3 over x plus 3. That's evaluated from 2 to 5. Plug everything in and we get this, which is essentially our final answer. You might consider going back to the original integral and making a substitution, keeping in mind that you have to change your limits when you make that substitution. Okay, that's all for now.